Hi, I'm Morgan Zhang. In this video, I'd like to share with you how to implement a local RAG system that understands text and images powered by Chainwin 3 VL model on Nexus Serve with the Gradle UI. Before I explain how it's implemented, I want to give you a super quick demo of what it feels like to use. Let's switch over to the project UI. The UI is straightforward. I split the UI into three clones: left, center, and right. The left side contains the management of files and some settings. Here, you can view or upload the files used for search. Here is the model and retrieval setting. There are also build or rebuild buttons to index everything. The middle part is the chat box. The right side is the area showing retrieve evidence. This is where we can see what the retriever actually found. I have got some document about Nexus SDK here. Let's see the action. If you want to try it yourself, check the Nexus SDK official GitHub repo. Under demos, you will see this RAG project here. I have already cloned the repo. Let's see how to set it up. Following the README, first, we need to open the Nexus CLI and run Nexapol to download the interface model and embedding model. This time I already downloaded them. And then we should run the Nexus serve and keep this terminal open. Next, create a new Conda environment. This step is optional but recommended. Then activate it and install the dependency. To save time, I already installed them. Once the pair work is done, you can run the RAG pipeline either from the command line or Gradle UI. Since I already showed the UI, I will quickly show the command line path. It will build the index first. Please wait a second. Okay, let me ask a question. It prints the retrieved trunks and the image here and output the final answer. Now, if you are curious how this is implemented, the overall process can be roughly divided into 5 steps. First, build a text pipeline to load, trunk, embed, and index documents. Second, build an image pipeline to encode images and index them. Third, build a retriever that pulls top-K text and image evidence for any question. First, build a chat caller that sends the question, the text context, and the images to Chainwin 3 VL model and streams the answer. Finally, use a simple Gradle UI to tie them together. Before we start, make sure you use Nexapol to download Chainwin 3 VL model and Jena embedding model. Then, make sure Nexus Serve is running locally. Keep the terminal open while we work. We also need to create a docs folder at the root of the project to hold content you want to search. Step 1 is the text pipeline. Concentrably, it's 4 moves. First, load and trunk your documents so we have small passages with a bit of overlap. Second, embed those trunks using an embedding model so each trunk becomes a vector. Third, index the vector so we can do fast similarity search later. Finally, store a small metadata record per trunk with field name, trunk ID, and a short preview. Under the hood, This step calls the embedding API on Nexus to turn our trunks to vectors, then writes the index and metadata to disk. Step 2 is the image pipeline. Here, the pattern is similar to the text pipeline. First, scan the docs folder for images. Second, encode them with the vision language encoder. Third, index the image vectors. Finally, save the image metadata like original path. At query time, we will encode the text query in the same space to retrieve the most relevant images. In the next step, we need to build retriever to turn questions into evidence. When user asks a question, the retriever does two lookups: top K text trunks from the text index and top K image from the image index. We will render the text hits as a compact context block and attach the image directly to the model input. Next is chat caller. This is a chat completion API call to Nexus Serve. We send three things to the model: a system message that contains the text context, a user message with a user's question, and the image as image input. Following this step, we will have a backend. Now it's time to make a simple front end with a tool like Gradle UI. This project has a lot of things you can customize. Here are some examples. Change the interface model and embedding model by modifying the global variables. The trade-off is simple. Usually, lighter models are faster, and stronger models give better quality. You can adjust the trunk size and overlap used when we split documents. Bigger trunks carry more context per hit, but can blur boundaries. Smaller trunks improve record granularity, but increase token count. There isn't a best setting. You can experiment as you go to find the setting that works for you. You can adjust the top case strategy. This controls how much evidence we pull from each index. If answers feel thin or miss detail, try to raise top K. If response get long or start drifting, try to load them. You can also refine the system message. This is where we set the ground rule for the model. That's all I want to share with you. Thank you for watching.